Hi, this is the first lecture of the subject, namely power electronics, and in this lecture we will study about this topic, which is Introduction to Power Electronics. And at the end of this slide we will be coming up with a conclusion what is about the importance of power electronics. So to understand its importance, we have to go through these topics. The first one is the power, and then electronics, and afterwards control, and then we will be having a block diagram, and then there will be a conclusion from my side with reference to importance of power electronics. So power, when we see the word power, then we come across with these three kind of operations which are very important and which are associated with power. The first one is the generation, which usually occurs outside the city, where it is where the power is to be supplied, and that power can be generated by using a nuclear power plant, a hydroelectric power plant, a steam power plant. In steam power plant, the water is heated with coal, converted into steam, and it is moving the turbine, and the turbine is connected to the generator, and the mechanical energy of the turbine is converted into electrical energy, and in that way how power is produced in steam power plant. And then we have a hydroelectric power plant in which the water is fallen from a height onto the turbine, and the potential energy of water is converted into uh, mechanical energy of the turbine, which is connected with the alternator or the generator, from where the mechanical energy of the turbine is converted into electrical energy, and then how this is how the power is generated in hydroelectric power plant. And then in the nuclear power plant we can have nuclear reactions moving the turbines, and then we have generator connected, which is converting that energy into electrical energy. So we have many other power plants, but just we have to discuss some uh, few topics, because the main intention is to understand about the importance of power electronics. Then when we come across with the power transmission topic, we see that when the power is generated, it is outside the city, and it is at a far distance from the city. And then when the power is generated, it is being transmitted to the city via transmission lines at high voltage and low current, because in power we have two parameters, the voltage and current. The greater the voltage, to keep the same power, the smaller will be the current, and higher the current, the smaller will be the voltage to keep the same power. And in that way, when the power is generated from the power station, it is being sent to the step up generator, which converts the voltage of the power to a higher voltage and smaller current values, and then the power is transmitted from one place to another place. And another reason for stepping up the voltage is that at high voltage and smaller currents we have low losses of the transmission lines. Then there is a power distribution. When the transmission line reaches the city of to where the power has to be distributed, it is being stepped down by the step down generator to a lower voltage, and then being provided to the commercial or industrial users or to the domestic users by further stepping down the power to 220 volts. So then we have electronics. In electronics, we come across solid state devices, which is the semiconductor devices, and in electronic devices and circuit subject, we have understood about the diodes, the transistors, which are used to control uh, our electricity from one place to another place or within the circuit. So the semiconductor devices, the purpose of these devices is to control the movement of current within a circuit and to move it towards a direction where it is needed. And we have other devices as well. We have conductors which can conduct electricity as a whole, and we have insulator which do not conduct electricity as a whole, while we have semiconductor devices which conduct partially electricity and which can be used to drive the movement of current within our circuit, and these semiconductor devices can also be said as solid state devices. So then we have electronic circuit, which is a kind of circuit which is having all the circuitry which is embedded on that circuit, and we have devices which are working together to produce an aggregate signal. So the circuits, in circuits we have the signal processing going on. We are switching the signal as well. We are amplifying the signal as well. Once the signal passes from one device to another device within the circuit, in which let's suppose we have 10 devices within the circuit, and when the signal passes through every device, the level of the signal decreases, and it has to be amplified. So that's why the transistors are better switches than diode, because they providing amplification along with switching as well. Then we have the control selective topics of the control systems, and we have these two kind of characteristics. One is the steady state characteristic and other is the dynamic characteristic. So let's see, we have over here the steady state characteristic versus the dynamic characteristic. Okay, so we have some images over here, and we can see a simpler image which can translate diagrammatically in a simplified manner of what is a steady state and what is a dynamic characteristic. So you can see over here, this state from here to here is a transient kind of state, or it can be a dynamic state in which the signal is changing rapidly, exponentially, while from this state to the end state it can be a steady state where the signal is not changing at a very rapid rate. So these two terminologies needed to be understood before going forward to understand the power electronic semiconductor devices as well as their converters, because we have devices and we have to study their characteristics, and to understand their characteristics we can be using these two terminologies. So that's why we are understanding it. So for the generation of power we can have different kind of fuels, which we can have fossil fuels, we can have renewable resources like water in the hydroelectric power plant, or we can have nuclear elements which can be used as a fuel for the generation of power. So our objective was to understand the motivation of power electronics and its importance. So we have gathered all the pieces together, and now we have to understand this block diagram, and afterwards we will be making a conclusion about the importance of power electronics. So you can see that this is a diagram in which a power is generated, and this is a diagram of a power plant in which we have a fuel over here, and let's suppose we have 100 kilowatt of power which is in terms of fuel which is uh, being given input to this power plant. Let's suppose we have a container of water over here, and this fuel is heating that water into steam, and 65% of the energy is being lost as the heat energy, and 35% of energy will be used to convert that water into steam, which will be a high pressure steam and is moving the turbine, and then the mechanical energy of the turbine is converted into electrical energy by a generator, and we can have, let's suppose over here, 1% or 2% of energy loss in this process as well. And then this generator, when producing electrical energy, the power, it is stepping up that electrical energy to a high voltage, uh, and then that high voltage power is being transmitted through a transmission line to the destination where we have the load, and till the end we have about only 16% of the power which is the useful power, while we have 100 kilowatt of power which is being input in the form of fuel over to this power plant, and we have achieved only 16% of the useful power which is being delivered successfully to the load, and we have a loss of about 84% or 84 kilowatts. So power is when generated, it is generated in the form of gigawatts, and from here turbine to till the transmission line we have the generator, we have the step up transformer, we have the transmission lines, and in this case we have about 10% or 5 to 10% of power which is being lost in this area, in which we have electronic devices which are doing the switching operation and are not behaving in an optimal or optimum manner. So power electronics provides us an in-depth analysis of the power converters and power semiconductor devices which can be used within that area, and which can provide us efficient operation. And then when the efficient devices are inserted in this generator, step up transformer and the transmission line, then this loss, which can be 5 to 10%, it can be reduced to 2 to 3%, and we can be saving a power of about 8 gigawatts, which is quite a lot of power. So by the motivation of power, this is the motivation of power electronics, and this is why we use power electronics, and this is its importance, that by utilizing power electronics we can save some energy. We can create it will create a lot of difference in that sense. Thank you very much.